Good morning, students. Today we will be discussing about physics of class 9 and the topic is gravitation, and under that topic we will be discussing about free fall. So as you all are aware of the fact that when two bodies are there and there is certain kind of masses are being there, and if they are placed side by side, and suppose we have two masses, say m1 and m2, and if they are separated by a distance, say d, then they are attracted towards each other with a force, and that force is g times m1 m2 upon d of square. Now today we will be discussing about what is the meaning of the term free fall. So when we talk about free fall, anything if it is being dropped from a certain height, say from a building or from certain height of anything, then the motion of that body under the influence of gravity is said to be free fall. So we can say the motion of body, under the influence of gravity is called free fall. Now when we are discussing about free fall, it is mandatory for all of us to understand how and the things will go on. So suppose that a ball is being dropped, so we have two different cases. Number one out of this is motion, downward motion or downward motion. Now what can we say about the velocity, acceleration and the distance of the body? So the equations of motion are, for downward motion, remember the number one is we have v is equal to u plus at. Always remember when we are discussing the downward motion of a body, then in that case the body is being dropped from certain height, downward motion, its initial velocity will be taken into 0 and the final velocity, say it travels a height h and thereby then hits the ground. This is ground, and in that case what happens is the initial velocity is 0 and so the final velocity v will be equal to 0 plus at, and that gives rise to v is equal to at. So this is the first equation of motion that we have had. Now I will talk about the variation. So velocity is now directly proportional to the time. If we increase the time, the velocity will increase. If we decrease the time, the velocity will decrease. If we go on in plotting a graph, then we can have since we are discussing the downward motion, and so therefore we can talk about this motion of the body, and now we are talking about this say we plot velocity in this side and the time is in this side, so what should be the, this is the origin, so what should be the, so since there is a direct variation between the velocity and the time axis, so we can go for a direct relation. As you can see over, the graph will be a direct one. So this is the number one case. Now we go for the second one, and that is the second equation of motion that we have is S is equal to ut plus of half at square. Now when we talk about this, then in that case we need to understand what is the meaning of this S is equal to ut plus half at square when we talk about this. So for this uniform and non-uniform motion of the body, we can have this as, since u is equal to 0, and therefore S is equal to half of gt square, because for downward motion always consider we have taken acceleration as plus g, and therefore we cannot say in a sense of great commitment and dedications that the displacement of the body is proportional to square of the time period. Now since d is constant, 2 half is also constant, so we can say as that the speed of the distance covered by the body that we have taken as s. If you just remember that, so that h is now equal to half of gt square, and therefore the height is now proportional to square of the time period. And height in the sense we can call it as the distance covered by the body. So if we plot the distance time graph, so we have this in this type of graphical representation, then we can have it like since it is proportional to the square of the time period, so the graph will be, suppose we plot this side as, if we are plotting this side as the distance x and this side as the time t, and this is the origin, then the graph will be, since it is a square, the graph will be a curved one, as we can just see onto the graph. So this is the graphical representation of what we have. Now moving ahead, we have the third equation of motion, and that is the equation of velocity and this acceleration relation. So v square minus u square is equal to 2as. So we can write over here, since v is not 0, so v square is equal to 2gh, and if we want to find out v, then it is root over 2gh. One thing I would like to just quote over here, if I want to plot the graph of say acceleration time graph, so what is the relation between acceleration and time, you will find that the acceleration is constant. It is constant and it has a value of 9.8 meter per second square. So it is a constant value. So we plot a graph between acceleration and time. So what we observe that the graph would be like somewhat this. Is a constant, and so if we plot a graph between this acceleration, say a towards this side and time towards this side, then we have the acceleration will be something like this. It is constant, a is equal to g, and that is equal to 9.8 meter per second square. Now since we are moving in this downward direction, so in graphical representation we generally use this Cartesian coordinate sign convention. So we concentrate about minus 9.g, because it is in downward direction we are considering that, so it is minus 9.8 meter per second square. So this is what we have seen all the three equations of motion under free fall of the body. Similarly, body is in for upward motion, then we have for upward motion what we have this acceleration this time will be minus g. We take because as we move upward, in case of free fall, suppose we drop a ball upwards, throw a ball upward, and what happens in that case, that the acceleration of the body remains constant, but the velocity of the body goes on decreasing. This means there is certain retarding force acting against the motion of the body. So this is minus g, and now at the highest point, suppose the body is being sent upwards, at the highest point its final velocity is 0. So this implies that a body may have 0 velocity, but it is mandatory for it that it is not necessary that the velocity 0 means acceleration of the body will also be 0. So that means the body has 0 velocity, but acceleration is non-zero, and that is still acting on the body at the highest point. So we have velocity, final velocity of the body is 0. So similarly, accordingly, the equations of motion v is equal to u plus at, that will change, and since v is equal to 0, u minus gt, so we have here as u is equal to gt. So this is one relation. Second, we can easily calculate the second relation as s is equal to ut plus of half at square. So now we can write like here as h is equal to ut minus of half gt square. This is the second equation of motion, and the third one is we can calculate as v square minus u square is equal to 2as. Now for downward, for upward motion, we have velocity, final velocity is 0, minus u square is minus 2gh, and therefore we have u square is equal to 2gh. So this is the third equation of motion. Alright, so now here we have seen all the three equations of motion of the body in case of free fall, and that the free fall is upward as well as the downward motion of the body. Now when we talk about certain things, so there is one question I am putting you for all of you people here, that question that you will have to do. So what is the question? The question is, as you can see over the board, a ball is dropped from a height of 80 meters towards the ground. Find the time it takes to reach the ground. In the second case, the velocity with which it hits the ground. So here we go. This is the question. So as you can see over here, the question is clear to all of you. This is the question for which you have to answer. A ball is dropped from a height of 80 meters towards the ground. Find the time it takes to reach the ground, and then we go for certain multiplication is there. So here it is now, okay. The velocity with which it hits hits the ground. So this is the question that you will have to answer. Now, when we are talking about this, we should just be thinking about more and more discussions over that period of timing. And so we just been talking about the more answers and more perceptions. Let us now have some quizzes as we have in case of the free fall motion of the body. So now as you can see, we have this quizzes. So the first question is, as you can see on the board, that state the following statement is true or false. So the acceleration due to gravity experienced by an object depends on its mass. So as we all have studied that the acceleration due to gravity of a body is independent of the mass. It remains constant. It depends only on the mass of the planet, not the body. And therefore, the statement is false statement. So if you submit this, you can see that is correct answer. Second one, state whether the following statement is true or false. The acceleration due to gravity is greater at the equator and smaller at the poles. So this is, we have seen in case of the variation of acceleration due to gravity. So the acceleration due to gravity is always maximum at the poles and minimum at the equator. So that it is against a false statement that we have seen. Now the second and the third one is determine the acceleration of the earth about the sun. So we need to find this way. There are given parameters are there, and so if we calculate, we use the formula. What the formula is? The formula is that we have seen in that case the force we have G m1 times m2 upon r square. Now if we find the value of acceleration due to gravity, how we can find it? So acceleration due to gravity, that we can easily calculate. Suppose there is a body, and suppose this is earth, and a body of mass m is kept over here at certain height. So this height is d, and this is the radius of the earth, and the radius of the earth is r. So the force acting on the body, this force is G m is the mass of the earth upon r plus d of whole square. Now since r is much greater than d, therefore we have this force as G m upon r of square. This is equation number 1. But this force itself is responsible for the acceleration that has been produced in the body. The body has been dropped from that height. So if we drop the body from this height, it acquires an acceleration, and the acceleration produced in the body is given by this force is equal to mass times the acceleration due to gravity. So if we correlate it, we have F is equal to G m upon of r of square, and so we can write down like this from 1 and 2. This is equation number 2. So we can write from 1 and 2. We have m times g, that is equal to G m upon r square. So now m got cancelled out, and therefore G is equal to G m upon r of square. So this is the expression for value of acceleration due to gravity. As you can see, that the value of acceleration due to gravity is independent of mass of the body. It is not depending upon the mass of the body. Rather, it is depending upon the mass of the planet. This m is the mass of the planet, mass of Earth. Here the planet we have taken as Earth, and r is radius of Earth. So these are the two parameters onto which we have just discussed and understood the basic on surface. I hope the point is quite clear to all of you. Any confusion so far? So if there is any confusion, you can ask regarding the confusions, and if not, then great, let us discuss more about how we have different cases of this equations of motion for free fall. Let us have what we have there.
What happens when you drop a ball from the top of a multi-story building? When a body falls from a height without the action of an initial force, it is said to fall freely. The only force that acts on a free-falling body is acceleration due to gravity. So, even though the initial force and velocity are zero, the velocity of the falling body keeps increasing in the positive direction of the force of gravity.
So this is what I have just discussed with all of you, that even if suppose the body is, if we have dropped a body from certain height, then it will reach the ground with the velocity. And now suppose if we send the body upward, and at the highest point the body will have velocity 0, but remember its acceleration is not 0, and it is the acceleration due to gravity because of which it will fall down again. So a body may have acceleration non-zero and velocity 0 at that time of incidence. So this is one aspect of our discussion. Now when we talk about the second aspect,
like any other moving body, the motion of a free-falling body can be expressed in the form of equations. These equations are known as equations of motions. Let's see what they are. For any moving body, we know the first equation of motion is V is equal to U plus AT, where U and V are the initial and final velocities and A is acceleration. For a freely falling body, U is 0 and acceleration A is denoted by G, which is the acceleration due to gravity. Substituting these values, we get the first equation of motion for a free falling body, which is V is equal to GT.